Uh, Page 7, question number 6. In this question, an object of weight W is on the slope at an angle theta to the horizontal as shown. The normal contact force R is there. As the theta increase, R will. Basically, what happened? First, we have to resolve this into components, the horizontal and the vertical components. So the weight is acting downward when we take an axis. So this is our axis according to the inclined plane. The angle of the inclined plane is same as angle the weight is making with y-axis here. So the component of the weight which is with an angle, this is a component of the weight which is with an angle. So we call this as W cos theta. And the component of the weight which is against the angle, that is equals to W sine theta. So basically what happened here, R is equals to the normal contact force, which is R, is equals to W cos theta. Now, as we increase the value of a theta, what is the relation between theta and sine theta? Theta and sine theta are directly proportional. As we increase the value of the theta, the value of the sine theta will also increase. But theta and cos theta are inversely proportional to each other. So if we increase the angle of or increase the value of a theta, the value of the cos theta will decrease. So for question number 6, we are increasing the theta. So as we increase the theta, what will happen to cos theta? The value of the cos theta will decrease. As the value of the cos theta, weight is constant. So as the value of the cos theta will decrease, the value of the R will also decrease. So as the theta increase, R will decrease. Why R will decrease? Because as a theta increase, the value of this cos theta decrease. If cos theta decrease, the value of R will also decrease. That is why option A is the right answer for this. Is it clear? Next, page 11, question 11. Question 3B2. The angle between the pull of the man of a box and horizontal is 35. Show that the pull of a man on the box is about 400 Newton and the contact force of a ground on the box is 620. This is the same question I discussed with you last week related to the topic forces. So basically what we have to do, we have to like resolve the force into angle. For B1, the angle between the pull of the man of the box and the horizontal is 35. So pull of the man and horizontal, this angle is 35. The normal contact force is balancing with the weight and the friction, because the component which is with an angle, so this will be the pull of the man is F, so it will be F cos 35, and against the angle will be F sine 35. So R is acting up, F sine 35 is acting up, weight is acting down, and F cos 35 is acting towards right and the friction is acting towards left. So in the question, The angle between pull of the man on the box and the horizontal, that is 35. Show that the pull of a man on the box is about 400 Newton and the contact force on the ground is 620 Newton. That's a downward force. So how we can work out this? So basically, there is no resultant force. The upward force was the normal contact force. R was there. And W sine 35, which is also acting, or F sine 35, which is also acting up, and the weight is acting down. So the upward force equal to downward force and the resultant should be 0. So I can say R my plus R is acting up, F sine 35 is also acting up. That is equals to the downward force, that is the weight. So we need pull of the man, so we need this F. So how to get or how to find this F? R is already given 620. We can find the weight. How to find the weight? Weight is mass multiplied by gravity. That will be the weight. And the mass of a box is 85, or here the 85 is there, multiplied by acceleration due to gravity, which is 9.8. So 85 multiplied by 9.8 will get the weight. So we have the weight, we have R, so we can find F. This will be weight minus R divided by sine 35. That is equals to F. Equal to 371.4. So F is, which is there about, so it is about 400, 371.4 newtons. The next part, the box move at a constant speed towards the man. Calculate the frictional force between the box and the ground. So if we know we want the frictional force between, because a box is moving towards the man with a constant speed. When if something is moving with a constant speed, what does it mean? It means the resultant force, again, it is 0. There is no resultant forces acting. And how we can work out this? So F is there, which is making angle 35. So the component which is with an angle, that is F cos theta or F cos 35, and against the angle is F sine 35. The friction is opposing it, so F is there. And there is no resultant force, or resultant force is equals to 0. So F already, which we worked out. So I can say F cos 35 minus frictional force is equals to 0, because as it is moving with a constant speed mentioned in the question. So the resultant force is 0. If resultant force is 0, so we can find this frictional force, or frictional force is equals to F cos 35. And F was already there, which is 371 cos 35. So it substitute the value, you will get the answer, which is 304. So F is equals to, the friction is equals to 304 Newton. The man increases his pull on the box. So he increases the pull on the box. The man and the box start to move together in the same direction with an acceleration of 0.2. So basically, if they're moving in the same direction, so this is like a two-body system, multi-body system in which we have two individual bodies, both have the acceleration of 0.2. Calculate the frictional force between the ground and the man. So man is trying to pull and the friction is opposing the motion. The mass of a man is 90 kilograms. So in this case, now there's a resultant force, or the force is acting, which is trying to oppose. So first, what we will find, we'll find the resultant force. How to find a resultant force? We have the formula F is equals to ma, like the resultant force of this on this system. So mass, because we are considering both are moving with the same acceleration, so multi-body system, the total mass of a box is 85 and the mass of the man is 90, multiplied by acceleration, which is 0.2. So when you multiply, 35 Newton is a resultant force. So how to get, because in the question, this 35 is a resultant force, but we need a frictional force between the ground and the man. So there's a friction on the man and there's a friction force between the ground and the man. So basically what happened, this system is having a resultant force of 13.5 Newton. And already we worked out in the previous example, the box move at a constant speed and calculate the frictional force. So we calculate the frictional force between the box and the ground. So this frictional force was 304. So man is trying to pull it and the friction is opposing it. That frictional force is 304. And we need this force. So resultant is equals to 35. So it will be F minus 304 is equals to 35. Or we can also say the friction on the man minus friction on the box, that is responsible for the resultant force. So this is 304, that will move other side. So F is equals to 35 plus 304. That is, so F is equals to 339 Newton. That is a friction on the man. Basically, the friction on the man is responsible here for the resultant force generated. Is it clear, this example? This is the same one we discussed last week as well. The next question is on page 11. Question 11. So in this question, again, this is a multi-body system, like when two objects are there. A car is towed by a truck using a rope. The car is pulled at a constant speed, creating a tension in a rope. The horizontal forces on the car are shown. So the tension is there and the friction. The magnitude of the force exerted by the truck on the car. So basically, what force is exerted? Like example, if I say a truck is applying a force of, a truck engine is developing, say, a resultant force of 30 Newton. So how a truck is applying a force on the car, so that the force on the car will also be equal to 30 Newton. So basically, here the tension is generated by the truck. And so in the question, we need a magnitude of the force exerted by the truck on the car. We don't want resultant force. They did not ask calculate the resultant force on the car. So if the question was the resultant force on the car, then it will be T minus F. But in the question, they asked magnitude of the force exerted by the truck on the car. So how much force? Actually, the truck is pulling this car. So the truck is applying a force or equal to the tension in the rope. But the resultant force on the car will be T minus F. Is it clear? That's why option C is the right answer for this. Is it clear, this part? Page 12, question 13a. A student carried out an experiment to obtain the value of acceleration of a free fall. A small ball was dropped from rest and the motion of the ball was captured using a camera. The student counted the frame from the recording and to measure the time. A ruler is visible on the recording to enable the student to measure the distance. Using the Newton's second law of motion showed that acceleration of a ball is independent of its mass. So how we can show acceleration is independent of this mass? We have the formula that the resultant force is equals to ma. But when the object is falling, like if there is a falling object, what is the resultant force? The resultant force is, if it is moving with a constant acceleration, the resultant force is equals to weight, because there is no force opposing its motion. So in place of F, I can write weight. So I can say weight is equals to ma. And W is equals to mg. So in place of W, I can write mg. So m can cancel with m. So what it shows acceleration is due to gravity and it is independent of the mass. Means if I drop a lighter object, I drop a heavy object, all will have the same acceleration. Is it clear, this part? This was question 13a. Then page 14, question 14b. So on the axis, draw corresponding velocity time graph for airplane. This is acceleration time graph. So basically, velocity time graph, the slope represent acceleration. Now, here you can see for 1 point, each box is representing 0.1. So 0.1, 2, 3, 4, 5, 6. So this is 1.6. So from time interval 0 to 1.6, what happened to acceleration? Acceleration is constant. From 1.6 to 3. So from 1.6 to 3, the acceleration is 0. From 3 to 7, the acceleration is constant but negative. The value is a constant but negative. Now I have to sketch a velocity time graph. And the labels are also important, like velocity label. How I'll know the velocity? Because if I know the constant acceleration is there and I know the time interval, so I can work out its velocity. We have the formula. If you consider initial velocity was 0, so v is equals to u plus at, or v is equals to a multiplied by t. So acceleration multiplied by, so from 0 to 1.6 second, it is a constant acceleration. If it's a constant acceleration, so for velocity time graph, so from velocity time graph, what I can do, I need a constant acceleration. So means from 0 to 1.6 second, acceleration for velocity time graph, slope represent acceleration. So if acceleration is constant, so 0 to 1.6, the slope should be constant. But till what point it should be constant? We have this formula v is equals to u plus at. So acceleration multiplied by time will give us the final velocity. Acceleration was 2 multiplied by 1.6, that's equal to 3.2. So the final velocity is 3.2. So if I light the number like 1, 2, 3, so each box is representing till 1.6 and 3.2. Acceleration should be constant or slope should be constant for velocity time graph. So what I will do, I will draw a straight line from 0 to 1.6 where the acceleration is constant or slope is constant till the maximum value of 3.2. Then from 3 to 7 second acceleration is 1.6 to 3, acceleration is 0. Acceleration 0 means speed is constant. Like acceleration can be 0 in two ways, either an object at rest or the speed is constant. But here, because already they mentioned it's a moving object, so how we will draw for a moving object, acceleration is 0. So acceleration 0 means slope is 0. Slope 0 means horizontal line. So from 1.6 to 3, I should draw a horizontal line. So from 1.6 to 3, I will draw a horizontal line. And from 3 to 7, acceleration is constant but negative. So I should draw a constant acceleration but a negative. So means slope should be constant but negative. From 3 to 7 seconds, acceleration is constant, so slope is constant. Slope represent acceleration. But it is a negative value. So how we'll draw a negative value? So we'll start from 3 and continue the constant slope until 7. Is it clear? The velocity time graph for from acceleration time graph. Is it clear this point? Then page 19, question 19. For this one, because here the slope is speed time graph, slope is decreasing, so velocity is decreasing, positive. So D in a marking scheme, I think I typed B, but actual answer is D. This was by mistake. But D is the right answer for this question. Page 19, question. In this question, a trolley rolls down a slope from rest. A trolley moves through a vertical height h while rolling a distance s. The maximum possible speed is given by. So how we can work out the maximum possible speed of this? Basically, because it is initially at rest, so initial velocity is 0. So if its initial velocity is 0, we have the formula 2as is equals to v square minus u square. Or we can also use the energy change So we have this formula 2as is equals to v square minus u square. From rest, so initial velocity is 0, so 2as is equals to v square. Now, as we know, what is the distance? Like here, if I use the energy change, the potential energy is converted into kinetic energy. Potential energy is given by mgh. Kinetic energy is given by half mv square. M will cancel with m. So gh is equals to half mv square or 1 by 2 mv square. So 2gh in a square root will give us v. This is when potential energy is converted into kinetic energy. When you are using this formula, if I'm using this formula, 2as is equals to v square. So when it is moving, I don't know, I know the vertical acceleration, because what happens when objects without air resistance, their acceleration is due to the gravity. But if I want to use this formula, like I have this, so v can be 2as in a square root, that can be v. But I don't know the acceleration here. Acceleration of the plane is not given. So if acceleration of the plane is not given, so what we use the energy change, that the potential energy is actually converted into kinetic energy. That's why 2gh in a square root will give us the value of v. Why not this formula? Because the acceleration is not given. We don't know what is the acceleration on this horizontal plane. So we did not use the distance s, we use h. That is why option D is a right answer. Is it clear? Because for vertical plane, we know its acceleration and we know the potential energy converted into kinetic, but horizontal plane, we don't know its acceleration. That is why we did not use that formula, that 2as equal to, and there's no option in which there's 2as, it's 2gh or 2gs. Is it clear, this option? Page 26. Page number 26, question number 22, B4, B6. Explain how the data for average extension of spring shows that the lift is moving upward. Average acceleration, in the beginning it was 0.4, then it is 0, and then it is negative, means decelerating. So how this data is showing that the lift is accelerating up. So accelerating up or decelerating down, you can judge from the value as you can see from the beginning. What is happening? In the beginning it was 12.7. In the beginning they start average extension, then the extension is decreasing, and in the end the extension is 11.7. So how we can make sure that lift is accelerating up? Or moving up? Because if lift is moving up, it means the resultant force is upward, or because it is not moving with a constant speed, that's why the acceleration is not constant. So as it is going up, if you have a spring system, the weight of a spring, the weight of an object, the downward force is there, and there's an upward force by the spring which is pulling it. So to have a if resultant force, if it is accelerating up or going up, it means that there should be a resultant force upward. If there is a resultant force upward, so what happened to extension? Will it increase or decrease? If there should be a resultant force upward, so extension or the length of a spring, the change in the length, increase or decrease? So it should decrease. So you can see from the data that what is happening to the average extension, this value of average extension, that is decreasing. So if the value of the average extension is decreasing, what it shows there is a resultant force upward, or we can say, so springs, in the beginning it is more, but as it is decreasing, that's why it shows that there's a resultant upward force, so extension is decreasing. Is it clear? Accelerating up or decelerating down having a same meaning. From the data we concluded that extension is decreasing, it means the resultant force should be upward. To have a resultant force upward, it should accelerate up or decelerate down. Then page 28, 29. During the 17th century, the physicist Galileo carried out a series of experiments investigating how the gravity affected acceleration. There were no accurate method to measure a short time interval. Like we cannot measure a short time interval. So Galileo used an object on a smooth inclined plane to increase the time for the object motion. An object is released from rest and slide a distance as down with a smooth inclined surface as shown in diagram 1. So diagram 1 is showing that object is moving down on this inclined surface. This will take longer than releasing an object from rest and allow it to fall freely through the same distance. So if you drop the object same distance, like example, if this was say 5 meter and we also drop an object from 5 meter, this will take a short time and this will take a long time, because acceleration on inclined surface is given by g sine theta, but acceleration on a vertical plane, that is same as the gravity if there is no air resistance acting. Assume that the frictional force between the plane and the object are negligible. Explain why the object in diagram 1 take longer to travel as compared to object in diagram 2. So already I answered this part. Basically what happened, because the accelerations, they are not having the same acceleration. Why they are not having the same acceleration? For one, acceleration is due to gravity times the sine theta, but for the second one, acceleration is due to the gravity, a is equals to g. That is why for diagram 2 there is greater acceleration, so it will take short time as compared to diagram 1. Is it clear? The reason why in the second one it will take, because basically if I drive a formula, the weight will act downward when we take the axis. So if we take the axis, the blue line is representing the weight. So this weight will have component, the angle with the inclined plane is same as angle the weight is making with the axis, the one which is with an angle, that W cos theta, against the angle is W sin theta. If the friction is negligible, so W sin theta is responsible for its motion is equals to Ma. And W is equals to mg, so mg sin theta is equals to Ma. M will cancel with them, so it means G sin theta is equals to A. But here what happened, weight is a resultant force of W is equals to Ma and W is equals to mg, so mg is equals to Ma, M will cancel with them, so A is equals to G. So it will have a greater acceleration on vertical plane as compared to on inclined surface. Is it clear, this part? For the next one, we need acceleration. So if we need an acceleration when when the theta is 35, so I told you acceleration is on the inclined surface if friction is negligible or neglected, a is equals to g sine theta. So 9.8 multiplied by sine 35, that will give you the acceleration on inclined surface. Galileo released a metal ball from rest so that it rolled down a smooth incline. The time taken for to roll down a distance s was measured. He repeated the experiment each time, recording the time to travel the different fractions of s. On the axis, sketch a distance time graph. Expect from these reading. Basically, what happened when object is rolling in the beginning, it will not like in the beginning. It's a distance time graph. So distance travel will be s. So in the beginning, it will travel slower, but its speed will increase as it will move. So speed increase, it means the slope should also increase. That's why we'll have a graph which the slope is increasing. Is it clear? For the next part, write an expression for time taken in terms of t for the ball to roll down a distance s by 2 from the top of the plane. Means s is a total distance. We want the expression for a time it will take in terms of t, like we have to include t, so that the ball will roll half, like how much time it will take to cover half of it. No, we don't have to draw the multiple graph, because in the question they mentioned on the axis below, sketch a distance time expected for these readings. So like example, if this was s, the total this was s, so this will be s by 2, this will be s by 4, this will be 3s by 4, and the total time is t. So the speed for every interval increase, that's why we'll get this answer, or the shape of the graph will be like this.